Lesson 4.1 is coordinates, distance, and the midpoint formulas in 2 dimensions and 3 dimensions. I would pause the video and write down these notes. So first, a little introduction into 3-dimensional space. So just like we have xy planes in 2 dimensions, we can also have 3-dimensional space with x, y, and z planes, or x, y, and z axes. So this is what it would look like. This would be your positive x-axis, your positive y-axis, and then your positive z-axis kind of comes up. So this is the way that we draw it. And then we have coordinates that are x, comma, y, comma, z. So this would be a coordinate in like the first quadrant where everything is positive. It comes out in an x distance in the x direction, it comes out a y distance in the y direction, and up a z distance in the z direction. So you kind of draw it like you would a 3-dimensional cube, and that's how you create this 3-dimensional space. So midpoint formulas. Midpoint is the point that's right in the middle of a line segment containing 2 points. So if you have two points in 2 dimensions, x1, y1, and x2, y2, then the midpoint would just be the average of the 2 coordinates, x1 plus x2 divided by 2, y1 plus y2 divided by 2. If you go into 3 dimensions, it's the exact same thing. You just have to have your z coordinate as well. So it'd be z1 plus z2 also divided by 2. So the points A, which is negative 3, 5, and B, which is 0, 7, lie on the diameter of a circle. Find the coordinates of the center of the circle. So go ahead and pause the video and try that. So here's my little picture of my circle here. We have A and B. So our center would lie right in the middle of our diameter. So that's the same thing as saying the midpoint of point AB. So I found the midpoint. So I added negative 3 plus 0 divided by 2 and 5 plus 7 divided by 2. So you end up with negative 1.5, comma 6. So that's the center of the circle. So in this next example, we have a midpoint, negative 3, comma 7.5, and we know it's the midpoint between points A and B, where A is x, comma 5, and B is negative 1, comma 10. So given that we know the midpoint, find the value of x. So if we're given the midpoint, so negative 3, comma 7.5 would be equal to the average of the x's and the y's, so x plus negative 1 divided by 2 and 5 plus 10 divided by 2. Since this one's complete, you don't have to worry about the y's. So I set negative 3 equal to x minus 1 over 2 and solve for x. So multiplied both sides by 2, negative 6 equals x minus 1, and then add 1 to both sides, and you end up with x equals negative 5. So this next example, we have a cuboid ABC O A1 B1 C1 O1, which has dimensions of 4 by 5 by 2. And the vertices have the base with the following coordinates. So coordinate A, or vertex A, is at 4, 0, 0, B is at 4, 5, 0, C is at 0, 5, 0, and O is at the origin 0, 0, 0. So first, sketch a coordinate system in 3 dimensions so that you have the cuboid, and determine the points of the vertices A1, B1, C1, and O1. So go ahead and pause the video and try that. So I sketched a graph of the cuboid here. So this is the positive x-axis, positive y-axis, and positive z-axis. Vertex A is sitting on the positive x-axis at 4, 0, 0. Vertex C is sitting on the positive y-axis at 0, 5, 0. Vertex B is out here in what would normally be our xy plane at 4, 5, 0. And then vertex O is at the origin here. I just left this in black on this side. So then A1, B1, and C1 and O1 would be the top of the box, if you think of it as a box, if A, B, C, and O are the base of the box. So they're all going to be up. So they tell us that the dimension is 2. So I know I'm going 2 in the y direction here. So I went up 2, up 2, up 2, up 2 from all 4 of my vertices. So if I take all of my vertices and I just move them up in the z direction by 2, A sub 1 would be 4, 0, 2. B sub 1 would be 4, 5, 2, C sub 1 would be 0, 5, 2, and O sub 1 would be 0, 0, 2. So now, given this information, we want to find the coordinates of the midpoint of the diagonal AC1. So the diagonal that goes across the corners of this box here. So go ahead and pause the video and find the midpoint M. So midpoint in 3 dimensions is the same thing as midpoint in 2 dimensions, except for you have to include your z coordinate. So I just looked at coordinate A and coordinate C1, and I just found the average of the x, y, and the z. So 4 plus 0 over 2 is 2, 0 plus 5 over 2 is 2.5, and 0 plus 2 over 2 is 1. So explain whether or not you would expect A sub AC1, so the diagonal that we just found, to have the same midpoint as A sub 1C, so going the other direction. So pause the video and decide that. So I found the midpoint doing the same thing, but looking at a sub 1 and c, and I got the exact same midpoint, which makes sense because when you have a cuboid like this, the diagonals are going to bisect each other. So midpoint formula, find the average of the coordinates. If there's 2 coordinates, x and y. If there's 3 coordinates, x, y, and z. And again, positive x-axis, positive y-axis, and then positive z-axis comes up. So next, distance formula. Distance formula is how you find the distance between 2 points in the coordinate plane. So same thing, if you have given a point A, x1, y1, and B, x2, y2, then the distance formula is the same thing as the Pythagorean theorem, which is the same thing as the equation of a circle. So distance is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So that's if you're in 2 dimensions. If you're in 3 dimensions, it's the exact same thing. You just have to include your z coordinate. So then you also add on the z sub 2 minus z sub 1 quantity squared. So we have a storage box that's in the shape of a cuboid, OCDRFBAQ, and it's given in this diagram right here. They tell us that vertex A has the coordinate 2, 3, 4, and all coordinates are given in meters. So first thing, pause the video and find the coordinates of the vertices R, C, B, and Q. So go ahead and pause the video and do that. So if you use this vertex A here, it's 2, 3, 4. That means that the furthest out you come in the x direction would be 2, the furthest you come out in the y direction would be 3, and the furthest you come out in the z direction would be 4. So then if I look at this vertex R here, it's sitting on the positive x-axis, so that means it hasn't gone in the y direction at all, and it hasn't gone in the z direction at all, so it's just going to be 2, 0, 0. C is going to be the same thing, but it's sitting on the y-axis, so it hasn't gone the x direction at all, so 0. It's gone 3 in the y direction and none in the z direction, so 0, 3, 0. B is sitting on the same plane. It's sitting on this yz plane here. It hasn't gone at all in the x direction, but it's gone 3 in the y direction and 4 in the z direction. So you're going to have 0, 3, 4. And then same thing is with Q. It's sitting on this xz plane over here. So it hasn't gone at all in the y direction, but it's gone 2 in the x direction and 4 in the z direction. So 2, 0, 4. So next says find the maximum length of a garden tool that can fit in a storage box. So look at this dotted line they have in here. Imagine you can fit it diagonally like this. So what is the biggest tool that you can fit in here? So go ahead and pause the video and try that. So if you want to find length, that's distance formula. So we want to find the distance between vertex R and vertex B. So we're looking at R, which is 2, 0, 0, and B, which is 0, 3, 4. So I have the square root of 2 minus 0 quantity squared plus 0 minus 3 quantity squared plus 0 minus 4 quantity squared, which ends up being the square root of 4 plus 9 plus 16, which is the square root of 29. Rounded to 3 significant figures, that would be 5.39 meters. So then go ahead, pause the video, and do parts C and D. Find the height, RQ, of the storage box, and then find the angle between the diagonals BR, so the diagonal that we drew right here, and the diagonal BQ. So you're finding this interior angle right here. So go ahead and pause the video and do parts C and D. So the height RQ is how far it's coming up, so that would just be this 4 in the Z direction here. So our height is 4 meters. So then we have a right triangle here, RQB, where we have one leg to be 4, and then we just found the hypotenuse here to be root 29. So we can use SOHCAHTOA because it's a right triangle. We're looking for this angle B here, so opposite and hypotenuse, which is sine. So sine of angle B is equal to 4 over root 29. So B is equal to the sine inverse of 4 over root 29, which rounded to 3 significant figures would be 48.0 degrees. So this has been distance formula and midpoint formula in 2 and 3 dimensions.